Okay, good morning to everyone. In the previous class, we were discussing about some of the factors which are going to affect in the self-verification process. So, some of the factors like the dilution, current, temperature, sunlight, and the rate of oxidation. So then, this is oxygen sac. This is very important as the examination point of view. Uh, Maybe they may ask for 10 marks. Define oxygen sac curve and explain the components of the oxygen sac curve. Then what is this oxygen sac curve is? As we know that what is its importance? Where exactly it will the river is flowing like this. And the wastewater you are discharging at some point. So the flow direction is like this. Suppose if you wastewater if you discharge at this point, how exactly the oxygen is go on decreasing or increasing based on the wastewater load or the organic load. I already said it is organic load. Organic load. How exactly it is going to increase or decrease as it move towards downstream. This dissolved oxygen sometimes it may increase or sometimes it may decrease up to some extent, and after that it will increase or it may decrease. It is based on many of the factors like the currents what we already discussed, and based on sunlight, based on uh, the wastewater, the characteristics of wastewater which we are releasing. So normally, how exactly it is going to happen in the rivers that we are going to study. So means oxygen sac or means how the oxygen is go on depleting and how the oxygen is go on increasing as it travels up to some distance in a rivers up to x distance and the time. These two are very important. At what time it is reaching to that distance and how much will be the oxygen that we have to find out. So the oxygen sag or oxygen deficit. Deficit means is always degrees. How much deficit is happening? How much oxygen is shortage? Deficit means shortage. A shortage in the sense we have to always compare with some of the standards. If we say that 6 to 8 milligram per liter is required in a reverse if it is a healthy. Suppose if we are maintaining at 2 milligram per liter, then deficit should be 4 milligram per liter. If you compare 6 milligram per liter will be if you take the value of 8. That much deficit is there. Required is 6.8, but deficit we are getting 4 or 6 based on these two values. So the oxygen sag or oxygen deficit in the stream at any point of time during the self-purification process. This T I already said. At any point of time, at any distance. During the self-purification process is the difference between the saturation DO content and the actual DO content at that time. Means normally it is whatever the oxygen deficit that we are talking about the saturation DO minus the actual DO. This saturation DO it depends on the temperature. For example, don't think that saturation DO is only for 0 degree centigrade. The saturation DO it with respect to all temperatures. For example, saturation DO at 25 degree centigrade. How much? The standards are there. Maybe the standard table I'll give you. It is 9.2 always if it is healthy. Saturation DO at 0 degree centigrade is always 14.2. These are all fixed values, irrespective of the actual DO. For example, 25 degree centigrade, what will be the DO? At 26 table is there. Maximum you are going to get that much dissolved oxygen in that temperature. That you can call it as saturation DO. Don't under the impression that it will be always 0 degrees centigrade, it will 25 degrees. It depends on the temperature. Temperature. For example, at 25 degrees, this is the maximum DO we are going to get. For 20 degrees centigrade, maximum DO we will get it. Actual may be different. Actual might be different. It depends on the organic load and the extent of pollution what you are doing in the rivers. But saturation DO is completely totally different from the actual DO. For this, standard table is available with respect to the temperature. Then actual DO, it depends on how much organic load you are transferring to the rivers. It may different. Maybe assume that at 25 degrees, you take one example. At 25 degrees centigrade, we can say it is 9.42 milligram per liter. This is saturation DO. Maybe at 25 degrees centigrade only, if you consider one what you can say, one river example, it might be different. Maybe it will be 6 milligram per liter if you are releasing more organic load. So always we have to talk in terms of this oxygen deficit is always with respect to saturation DO minus actual DO. Then the amount of resultant oxygen reflect can be obtained by algebraically adding the deoxygenation and reoxygenation curves. This we will discuss how exactly these two curves are very, maybe in 3 or 4 class before I have explained it. What is this deoxygenation and what is this reoxygenation curves? Maybe with the help of the curve, I'll explain how exactly this is going to happen. So we'll move on to this reoxygenation and deoxygenation curve. And we are using some of the terminologies also. This is a very important curve. With this definition, we are going to derive some of the Stirliffe equation in further class. But these terminologies are very important. So take this one stretch of river. So then assume that we are discharging at some point wastewater. So at this point, this is a percentage of y-axis. You consider it as a DO content, and this is time of flow, that is T, along with T. As it will travels with a distance, of course, it requires some time. Assume that this is one point. Assume that this is x1 distance, x1, and you can take it as a T1. Means if whatever the wastewater, if you are releasing at this point, it will travels up to some distance of x1 and it is taking time of T1. Then whatever this x, consider it as x, x1 equal to x with respect to this diagram, T1 is equal to T. Then when you discharge at this point, assume that it is 100% DO is there. That is a saturation DO. At this point, assume that 100% DO is there. Suddenly, when it will travels with some distance like this, as it travels with some distance, see what will happen is that DO, whatever the DO content will be there, it will be go on decreasing. Means as it travels, go on decreasing. Means the curve will come like this at this point. So this DO D naught means DO at 0 time. At 0 time. Means at this point D naught means 100%. Assume that it is 8 milligram per liter. Okay. At this point, saturation DO might be a different, but assume that the saturation DO at 25 degrees centigrade is 9.3 milligram per liter. But D naught, when it is discharged, liter. So now this one is saturation, what we are 100% talking about. D naught, you can take this stretch, it is decreased at that point time. Mean that much difference of DO is decreased at the first point. Then this is the point at time t. Assume that it is the time t where you can see that dt means DO at time t. At t here, what will be the at x distance and t time? This one is. So at this time, the DO is, the curve is coming like this. Means suppose if you are finding here also, no problem. This is with time t and the distance x. Then up to some extent it will travels, it will reaches like this. The curve will reaches at some point like this. It is completely, means at this point what is happening is that the DO is completely zero. Here DO is equal to 0 milligram per liter. This we can call it as critical point. Means here the fish will not survive. All the fish or aquatic life is going to die at this point. That point we can call it as critical point. Make sure that all the rivers should not be reached at this point. At least some DO should be maintained. That is critical point. And whatever the time taken to reach this critical point, we can call it as critical time, that is TC. Then this distance also we can call it as XC, that we have not mentioned it. It is TC as well as XC. This is T with a X. Then after some time, after when it travels with some distance, again as it move towards some distance, again the oxygen will slowly increase like this. So as it move towards some distance after crossing XC, so again the oxygen is coming back into the river. Here the oxygen is go on decreasing, but as it travels to some distance, the oxygen whatever it will be there, it will be go on increasing. So this up to this distance we can call it as deoxygenation curve. Deoxygenation means the oxygen is go on decreasing. After crossing XC point, so the curve is go on increasing. Means that is nothing but it is reoxygenation curve. Means oxygen is go on increasing as it travels along the distance. So that is why this is the reoxygenation curve. What the whatever means, oxygen is go on increasing, and this curve we can call it as deoxygenation curve. Of course, whatever this characteristics I am telling, it is with respect to kind of wastewater you are releasing and kind of the status of the river also. Some of the rivers, the curve, it will be looking like this only. It may take some distance. For example, some rivers may take around half a kilometer to reach this XC. Some of the rivers, it may take around 20 to 25 kilometers to reach this XC. It depends. Now we'll summarize it. So DO is DO naught. It is nothing but dissolved oxygen at 0th time. dt is dissolved oxygen um, at time t, at any time t. dc is critical do, and reoxygenation curve and deoxygenation curve. This is normally typical curve which is going to happen in all the rivers, but the distance may vary depending on the the kind of wastewater you are releasing or the kind of conditions of the rivers. It may vary from season to season also. In the winter season, the curve may looking like a flat if the wastewater is not releasing. Sometimes during summer season, the curve, whatever the critical point, it may reach early also. During rainy seasons, lot of fluctuations will be there, but this is a typical curve of any of the rivers. The deoxygenation and the reoxygenation curves, the curve which represents or showing the depletion of DO with time at a given temperature. Always will target it with the temperature. Then the reoxygenation curve in order to counterbalance of the consumption of DO due to the oxygen deoxygenation. The atmospheric supplies oxygen to the water, and the process is called the reoxygenation. Reoxygenation nothing but as it travels with a longer distances, normally the atmospheric oxygen is going to come and it will enter into the water. Then zones of purification. Um, this zones of purification we'll discuss in the next class.